we're going to go on and get started with the review. So looking at questions 1 through 3, are there any questions on problems 1, 2, or 3, stating the degree and leading coefficient? So the degree for number 1 would be what? 8, because the degree is the variable, well, the biggest exponent. Whatever variable has the biggest exponent will be the degree, because whatever that biggest exponent is. And so here, the biggest exponent is 8. And the leading coefficient is the number in front of it, so it would be negative 27. And that's it. For the second one, the degree would be 4, and the leading coefficient would be 6. And that's all we have to do for these here, degree and leading coefficient. So any other questions on 1 through 3? Are we good with 1 through 3? Okay. Questions on 4, 5, 6, or 7. One of those that we want to look at. So when we look at this here, we want to evaluate each function for the given value. So we're wanting to evaluate this for when x is equal to negative 4. Now we can use synthetic division to find this. Or what we can do is we can plug in negative 4 in for each x value. You can also use the store feature, store x, so negative 4 store x, and then type the function into the calculator. Or you can type it in like this here.
So where do we put the j? Do we leave the j out?
What's not a J?
Not a comma. What is that? Semicolon.
Oh shoot, that's probably why. Well, for a second there, like the first time we went through it, I thought it was I. It was a comma.
Would it be negative 8?
I believe so. So we're just plugging each one of those values in. Any questions on this here? So we're just plugging each one of those values in. We can do it with negative 7, 8, negative 12. And all we're wanting to do is just type in, replace x with whatever the value it's stated to be. And when we type that in and plug that in, after we plug in x for that value, negative 33, yes. Number 6. And that's all we have to do for these here. When we're evaluating for the given value, we plug it in and simplify. And that's it. Any other questions on these here? Determine if the following function is a polynomial function. Questions on these here? Questions on any of these here? Number 9. So there was a list that we had to determine if it wasn't a polynomial function. Well, one of the things was, so we cannot have negative, fractional, or variable exponents. There cannot be a negative, a fractional fraction, or variable in an exponent. If there is one, it is not a polynomial function. 2, we cannot have variables being multiplied. And when we talk about variables being multiplied, it's not x times x, we're talking about x times y or y times z. 2 variables being multiplied together would not be a polynomial function. We cannot have no radicals or variables in the bottom of a fraction. So no variables and being multiplied, no radicals, so no square roots, cube roots. A variable cannot be inside a square root or a cubed root or any other type of root, and it can't be in the bottom of a fraction. And I believe we listed out kind of these more expanded out because I think we had 4 or 5, but it was really made up of these 3 here. I've just simplified them together. Now, if we look at number 9, well, does number 9 have any of these here? Do we have negative exponents, variables as exponents, or fractions as exponents? No. Do we have variables being multiplied together? No, we just have the same variable all the way across. Do we have any radicals, variables inside of radicals? No. And any variables in the bottom of a fraction? So is this a polynomial function? Yes. Square roots, cube roots. How about number 8? Would number 8 be a polynomial function? No, because we have 2x to the negative 1. We cannot have negatives in an exponent. And that's it. Any questions on this here? Are we good with this here? Yes? Questions on 11, 12, or 13? This one here we're subtracting. Well, I can just write it over the top of itself. Like terms, so I have 2x to the 4th plus 3x cubed minus x squared plus x minus 4. Now what are we doing? So each one of these terms I'm going to 7x to the 4th minus 2x to the 4th. Negative 9x cubed minus 3x cubed. Negative 4x squared minus negative x squared. Well, the negative and negative would make a. Five x minus x would be plus. And 6 minus negative 4, well, negative make positive, which gives us we good?
Does one side always have to flip it? Like the leftward has to right?
So what are we subtract? So this is being subtracted from this. So that's why the 1 goes on bottom. They are not like terms. So we're adding them together, yes? So I don't have to worry about signs, so we can just go on and add like terms. Is there any x to the 5th or anywhere else? Okay, so I have 12x to the 5th. Negative 3x to the 4th and 8x to the 4th, we can combine those. Negative 3x to the 4th plus 8x to the 4th would be plus 4th. I don't have any cubes, but I do have some over here, don't I? Well, I would just stay. Because there's nothing to combine them with, they stay the same. And because it's plus, the sign stays the same. If it was minus, then we'd have to worry about sign changes, but I would set it up as this here. We don't have x squared, but I do have x's in both. 2x plus 4x is plus x. Negative 5 plus 1 is negative. And that's it.
I remember when I was talking about how I
Any other questions on this here? Okay. Questions on 14, 15, or 16? 14, 15, or 16? Any questions on these three here?
That's more or less a question on
18? We're just multiplying together, so I just need to pick which two I want to multiply first. So I can multiply the first two. And we're going to distribute, so we do 4 times 1, which is 4. 4 times negative 2x would be negative 8x. Then we multiply through by 5x. Now we're multiplying not all the way through, we're just doing these first two. We'll multiply with the next one after. Negative 5x times 1 would be negative 5x. And negative 5x times negative 2x would be 10x squared. Yes, I'm going to combine like terms here in a second. I want to do this first. So I would combine like terms. I want to rewrite this in standard form, which means 10x squared is going to go first. Negative 8x minus 5x would be negative 13x plus 4. And writing this in standard form is not completely necessary, but I would highly suggest combining like terms before you do the next multiplication. Now we're going to do this again. 10x squared times 3x would be 30x to the third. 10x squared times 2 is going to be plus 20x squared. Now I'm going to do something I call like a tier step or a stair step method for writing this next one. Because negative 13x times 3x would be negative 39x squared. Yes? I do this here because I'm lining up the like terms, so it's easier to combine them. Negative 13x times 2 is going to be minus 26x. 4 times 3x is going to be plus 12x, and 4 times 2 is going to be plus 8. And I do this here because now I can go straight down. We're just adding. There are no like terms with 30x cubed, so it's just 30x cubed. 20x squared minus 39x squared would be negative 19x squared. Negative 26x plus 12x would be negative 14x plus 8. And that's it. Any questions on this here? Any questions on any of this here? So with any of these here, only multiply 2 sets of those parentheses at a time. If there's more than 2, just multiply 2 of them at a time. Then simplify those and continue on. Any other questions on 17, 18, or 19? Any questions on 17, 18, or 19? Are we good with the multiplication? Okay. Anyone in particular on 20 through 24 on these here, on any one of these here that you all want to look at? Let's do 20. Now, because the degree of what we're dividing by, the x minus 5, is 1, I'm going to do synthetic division. So I need to solve x minus 5, set it equal to 0 and solve. So we would add 5. So we get x is equal to 5, and the number that goes in the cubbyhole would be positive 5. Now let's see the numbers going across the top. So I start off, our biggest one is x to the third, so it would be 1 for x to the third. Negative 10 for x squared. 20 for x and 26. And the first thing I do is I drop the 1. Then what do we do next? 5 times 1, which is? Add straight down. Negative 10 plus 5 is? Negative 5. 5 times negative 5 would be negative. 20 plus negative 25 is? Negative 5. 5 times negative 5 would be negative 25, which leaves us with any questions on any of this here? You will lose points if you leave it like this. Because again, this is our remainder, our term without x, our term with x, and our term with x squared, yes? So our answer that we actually have is x squared minus 5x minus 5 plus the remainder over what we were dividing by. And what were we dividing by? So that there is the answer. So if you just have left it with the 1, negative 5, and 1 inside the box, I would have counted points off because that's not the final answer. The final answer is our x squared minus 5x minus 5 plus 1 over x minus 5. This is the final answer. Any other questions on this here? Are we good with this one? Yes? Any other questions on 21 through 24 that we want to look at? Okay. Let's look at 22. So again, since this one here, the degree is 1, we can do synthetic division again. And I'm going to solve for x minus 1 equals 0. So at this point here, we're going to add 1 to both sides, giving us that x is equal to 1. 4, 3, 2, 1. And we fill in our terms across the top. Since we have our 7 comes from our x to the fourth, and negative 10 comes from x to the third, 3 comes from x squared, 3 comes from x, and negative 3 comes from our constant term. And remember, if we have any missing, because here we don't, we have to put in zeros for any term that's missing. Now we can do our multiplication. Well, 1 times 7 is? Negative 10 plus 7 is? 1 times negative 3. 3 plus negative 3 is? 1 times 0. 3 plus 0 is? And 1 times 3 is? Which gives us? So what that tells me is that x minus 1 divides into this evenly. It is a factor. And again, on this one here, if you leave this as the answer, you don't put anything else in, it will be counted off. I will count points off for that. Because we need to fill back in the variables. Because this here is our remainder. 3 is our term without x. 0 is the term with x. X squared and x cubed. So really we have what? 7x minus 3x squared. Well, I don't write that because it's 0. And then we have plus 3. Any other questions on this here? Okay. 24. Well, the degree of what we're dividing by is not 1, is it? So, on these here, we're going to do long division. This goes on the outside, and we have 3x to the fourth minus x cubed plus 8x squared plus 5x plus 3. And just like with synthetic division, if we have any terms missing, we have to plug in zeros for those terms. And now when we get started with this here, I look at x squared, and I see what times x squared will give me 3x to the fourth. It would be 3x squared because, well, 3 times our x squared will give us a 3. X squared times x squared gives me x to the fourth. And now we would multiply these together. And I'll do this up here, but I'll have to erase. 3x squared times x squared minus x plus 3. 3x squared times x squared is 3x to the fourth, which is just what we wanted. 3x times negative x would be negative 3x to the third. 3x squared times 3 is going to be plus 9x squared. And we put this right underneath here. 3x to the fourth minus 3x cubed plus 9x squared. So we put it right underneath there, and then we do what? We subtract. Because 3x to the fourth minus 3x to the fourth will cancel out. I should put that negative a little closer here. Negative x cubed minus negative 3x cubed. Well, this negative and negative would make a positive. Negative 1 minus, or negative 1 plus 3 is cubed. 2x cubed. We have 2x cubed. 8x squared minus 9x squared would be negative x squared. And we drop down our next term. Any questions on any of this here so far? Now we repeat the process. We see what times x squared gives me 2x cubed. Be plus 2x. Because 2x times x squared minus x plus 3, well, 2x times x squared is 2x cubed. 2x times negative x would be minus 2x squared. And 3 times 2x would be plus 6x. We put it underneath. 2x cubed minus 2x squared plus 6x. And again, we're going to do what? We're going to subtract. So 2x cubed minus 2x cubed, this would cancel out just like we wanted. Negative x squared minus negative 2x squared. Well, this negative and negative would make a positive. So we have negative x squared plus 2x squared, which would leave me with x squared. 5x minus 6x, negative 1x. And then we bring down the plus 3. Any questions on any of this here so far? You good with this here? Okay, now what times x squared gives me x squared? 1.
I'm just trying to figure out how did you get, like, at the first assessment, come up with 3x squared?
What times x squared? We get it. 3x.
Oh, okay, yeah.
Yep. And if we do our final subtraction, everything cancels because it's the exact same. X squared minus x squared is 0. So it does divide evenly. And this here is the final answer. If we had a remainder, we would just add on to the remainder whatever we're dividing by.
They also figure out how to do Algebra.
Okay, we'll do that here in a minute.
Okay, I'm gonna write all this down. All right, we should be good now.
Okay. Questions on 25 or 26? So for finding the rational zeros, we want plus or minus p over the q. Well, p and q, p is the factors of the constant term, which for this year would be 27. So I want all the factors of 27. Well, we'd have 1 and 27. Well, 2 is not a factor of 27, but 3 is. It'd be 3 and 9. 4 is not a factor, 5 is not a factor, so it works out these here are the only factors of 27. Factors of 9. We'd have 1 and 9. And then what? 3 and 3. And again, if a number repeats, we don't put it more than once. Piece of the what? Constant term. Q is the factors of the leading coefficient. Now to find all of them, we're going to do plus or minus P over Q. So I start off with Q being 1. So we do 1 divided by 1, which is 1. 3 divided by 1 would be 3. 9 divided by 1 would be 9, and 27 divided by 1 would be 27. And now that we've finished that one, because we used all possible P values, we move on to Q being 3. So we're going to do 1 divided by 3, which would be plus or minus 1/3. We move on to 3. Well, 3 divided by 3 is? 9 divided by 3 is? And 27 divided by 3 is? So we're done. Because it's all the values of plus or minus P over Q. So 1 divided by 3 is? 3 divided by 3 is? We already have it. 9 divided by 3 is? We have it. 27 divided by 3 is? We have it. Because 27 divided by 3 is? Let's move on to 9. So we do 1 divided by 9, which is? 3 divided by 9, which is? 1/3. We have it. 9 divided by 9 is? 27 divided by 9 is? And those are all the possible rational zeros. Yes. Any questions on this here? Are we good with this here? Yeah. And all the possible rationals plus or minus P over Q. Any questions on this here? Let's look at number 28. Number 28. So to find the positive, negative, and complex solutions, we're checking the sign changes. So for our positive ones, we just leave the function as it is and count the number of times the sign changes, from positive to negative or negative to positive. So if I look at this here, well, we've got 1, 2, 3, doesn't change, 4, and 5. There's 5 times from one term to the next that the sign does change. So the maximum number of positives that we can have is 5. Now to find the negatives, we plug negative x in to each of the spots where x appears. Now for this here, if the power of the exponent is odd, the sign changes. If the power of the exponent is even, it stays the same. So for the first one, we have for the 7th power, so the sign would change because 7 is odd. 5 is odd, so the negative 5 would become positive 5. 4 is even, so the sign would not change. 3 is odd, so negative 30 would become positive 30. Squared is even, so the sign does not change. 5 times negative x is just going to be negative 5x minus 6. Because x is to the first power, it is odd. And at this point here, again, we count the number of sign changes. So I have 1 for this here. From here to here, we have 1. It does not change. Does not change. 2. So for this here, the sign only changes twice. So the maximum number of negatives we can have is 2. Positive, negative, complex, total. Now, the degree for this was 7, so we should have 7 total answers. The maximum number of positive we had was 5. Negative was 2. So how many do I have total so far? 7. I need 7, so there's no complex. Now I stick with negative first. I subtract 2 from it. If I can, well, negative 2 minus 2 is 0, so that works. So if I have 5 positive and 0 negative, am I missing any? How many am I missing? So I could have 2 complex. Can I subtract 2 from negative now? No, because I go below 0, I get a negative number, yes? So I reset it, and this time subtract 2 from the 5, which gives me 3, 2. 3 and 2 gives me 5. How many am I missing? So 2 complex, because it'll give me 7. Now we go back to subtracting from the negatives. Because I can subtract 2 from 2, which would give me, so how many do I have total between positive and negatives? 3. How many am I missing? 4, because we want to get 7. Well, I can't subtract from 0 again, correct? So it goes back to, I can subtract from 3. And it would become, so I have 1 and 2, which has how many? So I'm missing. And now I can do it again from the negatives. And I'm missing 6. So I can't do it anymore for the zeros, correct? Can I do it anymore for the positives? No. We're done. Once I can't subtract 2 from either the positives or negatives anymore, we're done. We can come back to it. But any questions on this here? Any questions on any of this here? Okay. Number 29. 29 through 34 solve each polynomial function. You're wanting to try to find all the values of x that will make the function equal 0. And what's the first thing we would do on any of these here? Plug it into the calculator. So if we did this one here, how many zeros should I have? The degree of the polynomial function is? And according to the fundamental theorem of algebra, the number of solutions this should have is 4. And if we graph it, we would see on the graphing calculator that it crosses the x-axis at negative 1, 1, 2, and 4. Are there any more values I need to find? This here is the same as saying I found all 4 values, yes? I'm done. Solve it. So what values make it 0? Well, negative 1, 1, 2, and 4, because that's where it crosses the x-axis. When we graph it, we needed how many solutions? Do we have 4? We're done. Any questions on this here? So on this one here, when you graph it, yes, I would agree that it will cross where x is equal to 3. Well, since it's a degree 3, if I'd use synthetic division or I divide it once, it'll bring it down to a degree 2, which is a quadratic, yes? We can solve quadratics. So let's use the synthetic division. We would put 3 inside the cubbyhole, and across the top we'd have 1 for x cubed, negative 11 for x squared, 41 for x, and negative 51. We drop the 1. Well, 3 times 1 is 3. Negative 11 plus 3 would be negative 8. 3 times negative 8 would be negative 24. And this here would be positive 17. And 3 times 17 is, which gives us 0. Now, we knew the remainder for this is going to be 0. Because x equals 3, when x is 3, the function is equal to 0. It is a factor, so it should be 0. But what we know about this now is this here is a quadratic. This here is our remainder. 17 is the term without x. Negative 8 is the term with x, and 1 is the term with x squared. So what we have left over is x squared minus 8x plus 17. Since it is a quadratic, we're just going to use the quadratic formula. I'm not even going to attempt to factor it. It's just going to be easier to do it this way. Well, negative b. Well, that'd be negative 8, which would be 8, if you can get that, Zach. Plus or minus the square root of negative 8 squared. Minus 4. A would be 1, and c would be all over 2 times 1. Now, at this point here, I would plug everything inside the radical into the calculator. I wouldn't use the graphing calculator. I would stick to the 30xs, the yellow ones, because it'll simplify radicals. If we need to simplify the radical, it'll do it for us. Now, this here, 8 squared is going to be 64. Minus 4 times 7 is 8, carry the 2. We get 68, so this should be negative 4. And we're looking at 31, yes? Okay, good. Now, I need to simplify this radical. Well, the negative is going to come out as I. The square root of 4 is 2, and this is over 2, yes? Well, will both of these divide by 2 evenly? 8 divided by 2 is? And 2 divided by 2 is? And that's it. So most every single one of the ones that you have to solve, you will be able to find enough values from graphing to be able to get it to a quadratic. You will be able to find enough values to get it to a quadratic. And you can solve from there. Any questions on this here? Well, you'll probably have questions on this one here. So I could start off with graphing, but what do we notice is in common with both of these here? 9m to the third. They have a greatest common factor, yes? Well, 9 out of 9 will leave us with 1. If I pull 3 m's out of m to the fifth, I'm left with m minus, because 27, if I factor 9 out, if I divide it by 9, I'm left with 3, yes? over here, I can set both of these equal to 0, yes? I can divide both sides by 9, yes? Well, that just says m cubed is equal to 0, yes? Well, I'm going to break this down a little bit further. M to the third, well, that's really just saying m is being multiplied by itself how many times? 3. So really what we're saying is that m times m is equal to 0, yes? If I have more than one thing multiplied together to equal 0, one of them has to be. So we could say what? That m is equal to 0, or m is equal to. So that's the only way that works. Now, for m squared minus 3, it is a quadratic, and you can use the quadratic formula. I don't normally do that because do we have a middle term? So let's get m by itself. So I can add 3 to both sides, yes? M squared is equal to. What's the square root of m squared? I can square root both sides. And the square root of 3 would be plus or minus the square root of. So how many solutions do I have here? 5, because I have 0, 0, 0, square root of 3, and negative square root of 3. How many did we need? We have them all here. And the graph really gave us these three here. We would just need to know that 0 appeared 3 times. Questions on this here? A real big trick, and kind of what I notice, and it's pretty, and once you see it, it's kind of hard not to see it. If this is equal to 0, do I have any constant numbers? Do I have any term without a variable? So 0 has to be a solution. Because if I plug 0 in, well, everything will go away, yes? So anytime I have a higher degree polynomial or any polynomial function that has variables, has x all the way through it, I don't have any constant terms, I don't have terms without x, well, hey, 0 must be a solution. Because the only way that it wouldn't be is if I have some number being added or subtracted. Because if it's all variables, if I plug 0 into every single variable, everything becomes 0, yes? So that's one thing you can look out for. Now, are there any other questions on solving any of these here? On 29 through 34. So the main thing with solving is, well, we use the graphing calculator to get us any whole number answers, positive or negative. Then we use synthetic division to either get it down to a quadratic, or if we have them all, we're done. Like the one we saw, because it gave us 4, we needed 4, we're done. But if it doesn't give us all of them, we can use it to bring it from whatever the degree it is. So for this here, it'd be degree 3 down to degree 2, and then use the quadratic formula. Any other questions on this here?